And now, last but not least, the moment that a lot of us have been waiting for. Today, together with CIMBID, we're launching one of its flagship services, the Flywheel service, which will allow investigators across Colombia and hopefully soon across the tripartite to have access to imaging data for research at scale. With that, we'd like to welcome Howie Pollard to give us a presentation on the capabilities of Flywheel, how to get access, and how you'll be able to use it in your research. Thank you, Howie.
Okay, well, thank you so very much. And much like everybody else that's been here today, I certainly want to thank Dr. Contos, Sachin, and all of the folks who have worked so hard on the launch of this center. For me personally, I feel like this has really been a fantastic journey. I have had the privilege of working with Dr. Contos now for the last 4 years or so. I met her back at the University of Pennsylvania, and we started working on a project, one specific project, because she actually wanted to find out, was Flywheel a type of platform that could work for what she wanted it to? So over the course of about 12 months, we worked through this project. And at the end, I think she was fairly convinced that the idea that Flywheel was a very good platform for the curation of data, for the ability to collaborate with other researchers. And so as we were thinking about how could we make the University of Penn greater, it was about 2 years ago, almost to the date, I believe it was actually June 27th, I walked into Despina's office and I wanted to talk about how we could start to grow some things. And she said, I love your ideas. She said, but I have a slightly different plan in mind. And it was over the course of the next few months that she started to unveil to us that she was going to be coming and thinking about growing this new center. And all of that seemed like a pie in the sky, 2 years ago. And it's really not that much time that's gone by, and here we are. So, congratulations to all of you for, such an accelerated launch on what is really going to be something that's going to be fantastic to follow over the next course of the few years. So, again, we're so happy to be here and to be part of this, so thank you. I have a video that I do want to show, but prior to introducing Flywheel through the first video, I just want to comment on a few things that were said throughout the presentations earlier today, and the fact that they align so well with what the mission behind Flywheel is. And just to read a few notes that were taken, AI helps connect the dots across space, time, and scale. I wouldn't mind changing that to say Flywheel helps connect the dots across those times as well, because that's kind of been our message to people as we've talked about it. AI does not function in a vacuum. It interacts with, explains to, and supports humans. I need to steal that now for my marketing pieces because that is a brilliant statement. And again, at the heart of what Flywheel truly does, that is what we are here to do. We are here to support you, the humans, who are working on AI, working on decision support, working on all of the things that are truly going to make this precision medicine. So I'm going to step on here to the next slide, hopefully.
AI technology offers an unprecedented opportunity for healthcare innovation, including optimizing care workflows, the discovery of novel biomarkers, and improvements in diagnostic precision and outcomes. However, the healthcare and life sciences community faces challenges in identifying and accessing vast amounts of high-quality, diverse data within both their organizations and their collaborative networks. Medical imaging data in particular is incredibly powerful in developing AI, but it must be well managed, labeled, and curated to develop meaningful algorithms and discoveries. Managing such complex data eats up valuable resources, with up to 80% of research time dedicated to curating and preparing data for training and analysis. At Flywheel, we believe data should drive your innovation, not inhibit it through time-consuming and error-prone manual processes. Flywheel is a cloud-native medical imaging data and AI platform that enables the management, curation, and analysis of medical imaging data to extract and mobilize valuable insights. Flywheel provides an infrastructure for complex analysis, including machine learning, by making data more structured, accessible, and standardized. Our products enable the creation of high-quality, standardized datasets for training AI models, providing the needed secure and scalable infrastructure to prepare data for model development, testing, and deployment. From accessing vast amounts of diverse data through our data exchange to streamlining the discovery of patient cohorts, automating processing and machine learning pipelines, and enabling secure collaboration, Flywheel is an end-to-end solution for researchers and healthcare professionals to fully unlock the value of their medical imaging data.
Okay, now rather than the reach out for a demo today, although we will not be going through a full demo of what the software looks like, if there is anybody who would actually like to go through a demo of the software, I would highly recommend if you could email myself, Despina, Sachin. They certainly can get us information about getting that, and we can set up some demonstrations so that we could go through, walk you through the platform, and take some time to be able to show you what the capabilities of the actual platform are as they exist. What we're going to do today now is just walk through a little bit of the value prop, as we've talked about this, of what Flywheel is that it brings. And as we go through, if you have any questions, please feel free to stop. So a lot of the themes that we talked about earlier today, I think you're going to see in our slide deck, because again, as you talk about the mission of AI and what AI means to the medical community, that mission is very similar to what it is that Flywheel started out trying to do. And so when we look up here, healthcare data comprises 30% of the world's data volume. When we talk and we look at some of the statistics, some research shows as much as 50 petabytes of data coming out of a hospital system in a given year. Now, that may not be every single hospital, but we do know that every hospital is pumping out petabytes of data. Of that data, we know that about 80% of that data is radiology and imaging specific. So again, it brings us to the point of why we're here and why this is so important. How many of those insights that have been recorded over time are sitting in our PACS, are sitting in our VNA, or just sitting in disparate, siloed places. So as we look through, and again, we talked about the 80% of that medical data volume, that number rings true throughout even your research. One of the missions of Flywheel is to give you back the 80% of time that you've currently been using for looking for data. I've heard so many different people today talk about finding data. Where do we get data from? How do we share data? Where do we get it and bring it all together and work on it? And that's the idea behind Flywheel, is to take basic data, curate it, standardize it, and make it usable for everybody, not something that is usable for just neuroradiology or just an Alzheimer's group or maybe our oncology group. I know we see that a lot. We see a lot of siloed data throughout, whether it's in academic, whether it's in life sciences. I think we heard from Merck earlier today, and I think one of their bigger challenges is trying to find places to get data, right? So the ability to actually share data and work through that data is a hugely valuable aspect. I believe Despina talked about this earlier. 80% of the algorithms, the AI algorithms that have been approved, have been for radiology. And again, that speaks to the large amount of imaging data that we have that truly we're not necessarily getting the value out of. So what are some of the common challenges that we face on a day-to-day basis when we think about imaging research? And so as we look on the left here, hidden data, and I think that's what we've been talking about a lot throughout this entire day, and I think that was the beginning of the talk here, is we talk about siloed data, hidden data. I love to tell a story where I walked into an academic institution, it was not Columbia, by the way, and I was meeting with a researcher. He was a neuroradiologist, and he said, I really think Flywheel can help me. And I said, well, what is it that you're really looking to do? He reached under his desk and he pulled a huge box out and he put it on the desk, and dust flew everywhere. I said, what is that? He said, these are my DICOMs. These are my CDs. I need you to get these in Flywheel. I said, oh my God, this actually still exists. I came from a world prior to being at Flywheel where I worked for the PACS industry. And so, sharing, being able to, burn DVDs, that was something that I thought we were getting beyond. And again, that just highlights another reason why a platform that allows you to be able to share your data, be able to work within your data with all of your colleagues becomes such an important part of this. So again, another piece of this as we talk about it is on-prem systems. A huge thing that's been talked about throughout the entire day today has been the use of the cloud. We have some wonderful representation from our folks at AWS, and we know that folks from Microsoft, GCP, and all different companies are working on all different types of solutions. But yet, when we walk into so many different research institutions or so many different academic affiliations, everything is based in an on-prem system. And one of the challenges of that is, how do you get to that? I know we've talked about the VNA earlier today, and we talked about a PACS. It's hard to get data out of a PACS or a VNA. It's harder to get data out of somebody's hard drive when you don't even know it's there. I mean, all of these types of challenges, that all goes into the idea of an on-prem system of data that's not being shared out with everybody internally. Wasted time. Everything that we've talked about throughout this day today was talking about process. It was talking about pipelines and workflows. The idea behind Flywheel is, again, we talked about giving you back that 80%. So what does that mean? That's automating your pipelines. It's the idea that you have an automated ingestion so that when imaging is being brought in or data is being brought into Flywheel, it runs automatically through a DID protocol. It runs through a gear pipeline where if you're doing neuroradiology, everything that you needed to have done to have your data curated and structured in a basic manner is going to be done before you even sit down. So again, wasted time when you have multiple people sitting and doing different parts of the science, trying to get the data to a state where you're going to start working on analysis. Complex compliance. I think we've heard quite a bit today about IRBs, and so one of the things I believe that Flywheel will help in bringing here is going to be a little bit of structure around not only just that IRB process, but how do we collect data? How do we find data for our projects? And even in talking about drug discovery, if we have a cohort builder that allows us to be able to say, instead of going to a medical record number and having to figure out how many people maybe have a disease state, might be using a certain drug, wouldn't it be easier if we actually had a cohort builder or something to that effect that allowed us to look at our VNA or all of the data that we had and sequentially be able to say, okay, I'm looking for somebody who's 50 to 58 years old, they're male, they have a tumor, they have high blood pressure, they may have high sugar. All of those things that you want to be able to look through and actually get that from a system and then say, okay, in my VNA, there are 5,000 patients that actually match this criteria. Now, we're not there right now today, but that's what we're working towards, and we expect to be there within the next 12 to 15 months. These are all things that are going to help when it comes to wasted time and, again, with the complex compliance. Last, we have wasted resources. When we first started here with Columbia, I asked a question, and it's a very normal question that we ask everybody. Do you have any HPCs on campus? Because we like to be able to connect to your HPC setup, because as much as we understand the need to burst to a cloud, we still want the ability for you to use your on-prem resources. And Columbia blew me away. I said, how many HPCs do you have? They said, well, at least 7 or 8. I said, you have 7 or 8 different HPCs that you're sending all of your imaging to. How do you keep track of that? They said, I'm not really, it's kind of up to the researchers, right? So having compute management is really important, right? Being able to know, where are you sending it? Why are you sending it? How much are you sending it for? All of those things, they become pretty vital, right? So, I've spent a lot of time on this slide, but there's a lot of challenges when we think about medical imaging. There's a lot of things that we have to try and overcome just to start doing research. So this slide goes right along with what we were just talking about in the challenges. So isolated systems, unilateral data flow. How do you work if one system doesn't work with another? I mean, how many times right now in your research or in your pipeline do you actually have to go between multiple different softwares to achieve an outcome? That's something that, as you think about a platform should allow you the ability to work within it at all times. It should give you the ability to work with governance, with provenance, with the ability to follow an audit trail so that if changes are made, you know where the changes were made, you know when they were made. If you needed to understand the versionality of an algorithm, that should be available to you. These are the types of things that Flywheel allows by creating an overall platform system. So again, instead of using disparate systems, instead of having one place where maybe I try to ingest, if I'm trying to ingest into even a cloud bucket, then maybe I take that from a cloud bucket, I may try and download that again through an open source software and then run some results on that. When I upload that back up to the cloud, I have no way of knowing what happened to that data. Neither do any of my collaborators. Nobody has any idea maybe what I did with that once that's uploaded back up. When you have a platform that is actually, again, we talk about compliance, we talk about the ability to stay within that platform, have dual access from within the same credentialing that you use for getting into your computer systems today. This is going to lend itself to the ability to be able to not only do faster research, be able to accelerate your research, and be able to share, within your institution as well as externally. I'm going to skip this slide here because that was about the same thing. So when we look at the slide on the left, this is really the current paradigm that we see. Now, one of the things I would like to point out here is that, we talked about ingest and curate as being maybe one aspect or one challenge in general. When we talked to the folks at, Sacha and Despina, and we talked about how are people doing that today, again, the answer that came back was multiple ways, right? There are people that are, we may be trying to get something from a PAC system. People are trying to upload things just on their own through their own computers. There may be command line interface that people are utilizing, but there's not a single process that allows for ingestion of DICOM data. So in bringing in something like Flywheel, what we're going to do is use an integrated platform so that all of your ingestion is going to come through one centralized area so that you know that your data is going to land in one place and be able to be discerned from that point. View, annotate, and label. When we think about all of the different processes that you are doing currently, how many people in the room are currently working on video? Anybody work on video? Okay, we have one lone sole person working on video. So when you do video and you're looking to do annotations and segmentations of video, there's probably not a lot of tools. You have less tools at your disposal than the rest of the imaging folks do technically right now, because video seems to be a little harder to work with, right? So how do you get through working with that? And that's what we're working on now. We have tools that are coming out that are going to work with things like video outside of what's already working. We can already annotate, we can segment, we can automate all of that when you talk about static imaging. Now we're starting to work through where we can do that with the video imaging as we start to expand out through what our system is. Analyze, develop, and then deploy and collaborate. I'm going to skip to this next slide here because I think it talks a little bit better about what Flywheel is. When we traditionally talk about Flywheel as a platform, we would discuss it under what we would call the 4 C's, and those C's being the ability to capture data or ingest it, the ability to curate that data, the ability to run compute or manage your compute, and then the ability to collaborate. And so when we think about that, that's a lot of different pieces of management all in one. So it's not just an ingestion management. It isn't just being able to find your data. It's also a compute manager. Again, we talked about the ability that it's one thing to have an HPC, and you want to be able to use the investments that your institution has already made. So we have the ability to say, if you want to run something on your internal HPC, we can do that. But we also want to give you the ability for those really large data sets, or maybe there's a lot of people in line for the HPC, so that you can dynamically burst to the cloud and have that ability. So having a system like Flywheel is going to give you options for compute management. Ancillarily, when we think about different modules that are in Flywheel, we're going to expand that out even further and talk about the ability to use things like GPU gears, Jupyter notebooks, reader modules. When you start thinking about all of that, now you're getting the idea behind what actually is a full-on sized platform. So rather than having one tool again, and I keep going back to this point because this is, I think, what we've seen really in the overall pipeline of research is we have lots of different individual tools that we like to put together. Why wouldn't we bring these into one platform where everything can be seen, utilized, and then replicate it as we need to move forward? So again, the Flywheel advantage. Why Flywheel? Why would we want to bring Flywheel in? And as we see up here, significantly reducing cost. Okay, so an annotation platform that is built on top of the Flywheel had a 90% cost when it talked about laborious pixel redaction. So one customer that we had as we started to work in with that video, we saw a 90% reduction in what their overall cost was for this type of work. I'm going to go over to the enable faster analysis because if we look at another case study, we worked with one of our customers, this was specifically at the University of Wisconsin, and one of their goals during COVID was to create a model that would allow them to triage their patients in the ER very quickly and decide whether or not that they needed to be in an isolation room versus a non-isolation room. They brought in thousands of chest x-rays. They were able to create models. And basically now, because they used Flywheel in all of the data management, as well as they used some hardware from NVIDIA, they had peer storage as well. So there's a few other things that got tied into this. But utilizing Flywheel as their data and their compute management, they were able to take what would be 9 months worth of work and bring that down to 1 day, so that now they have the ability to continue to train that model and also validate it, because it's one thing to be able to create a model and be able to create that through your system, but then how do you validate that longitudinally? And Flywheel, because you can add live data to it on a regular basis, allows you to be able to not only create models, but also be able to validate those models over time. And then last but not least, we have the ensure secure collaboration and governance. I think that's been something that we've heard throughout every single talk today, is we've heard governance, provenance, the ability to know where the data is, what has happened to the data, and what are we planning to do with it next. Flywheel has a complete list of every single patient, every single session that's been brought in. You have provenance, you have the governance to be able to see what has happened, whether it is a gear, and when Flywheel talks about gears, we're talking about a Docker containerized algorithm. Any of those gears are available within the website. You have the ability to be able to add those to your automated pipelines, but they're all versioned. And so if you're using one version of a gear, say we're using something for fMRI prep, and a new version came out, you have the ability to be able to go back, batch look at all of your analysis that you've done in the past. You have the ability to go through and look at any site, any amount of information that you have, and run analysis through these different versioning tools. So we have a lot of different ways of going about talking about what Flywheel is capable of, but the overarching theme here is that it is one platform that allows you to do multiple different things. It's not something that is specific to radiology or neuroradiology. There are, something that we look at is all of the different ologies have a different need base for Flywheel. Oncology specifically has been something that over the last year or two, we have worked as a company to strengthen our story when it comes to oncology. Part of that is thinking about how do we integrate with a lot of the other systems out there. In the oncology space, I've had a lot of people ask me about using things like a MIM viewer, integrating with Mint. And all of those things are actually possible utilizing Flywheel. And one of the beauties of a system like this, it has open APIs, and it allows you to work very interoperably with any of our cloud partners. So you can always use something like an S3 or a blob storage as an intermediary, which allows you to do a lot of interoperability and connectivity within the Flywheel platform. So I'm going to move to one last slide here, because I would be very remiss to not talk about the ability for Flywheel to provide professional services. Certainly, as we talk about Flywheel as a commercial team, there's about maybe 15 of us when it comes to the actual sales piece of it. But the heart of Flywheel is the engineering team, and it's all of the engineers that are available that can also provide professional services. So I like to think of our professional service team as, if you can think it and dream it, they can build it. They've been very good when it comes to that. Now, we provide all different types of services. So if you're somebody who's a little bit newer to, say, neuroradiology, and you want to learn how to go through BIDS curation, we have professional services that would allow our people to be able to work with you and talk through things like that. If you're looking to kind of build something out with an SDK where you want to create your own integration, we again have people that would have that ability to work through that with you and kind of help you with your project. Again, these are folks who came from academia, came from life science, and have been working for years in data science. So now their whole intention is just to be there to support whatever it is your projects are. So lastly, I'm going to put this...
Flywheel provides researchers with a best-in-class...
I thought that was you asking a question. I forgot they told me as soon as I go to the next slide, it's going to automatically start. So the next slide is going to be a quick movie here. What I wanted to show you here, this is a 2-minute video that talks about AI modeling, and specifically in the world of oncology. If you're not part of that world, please don't think of it as only in oncology, because obviously this can be applied to any ology, but as I was saying earlier, this is something we've really been working on a lot lately, so certainly we want to be able to talk a little bit more about the oncology space.
Flywheel provides researchers with a best-in-class, end-to-end AI model development suite for medical imaging. If users have access to their own data, it can be imported into the system in a multitude of ways including case-by-case via our web uploader, in bulk from the cloud, or automatically pulled off of the imaging instrument. As data flows into the system, users can leverage Flywheel's Gear framework to build automated curation pipelines. This streamlines metadata extraction, image classification, and initial quality control. With your data through the automated curation pipeline, Flywheel users can then orchestrate human-in-the-loop reviews of the images using our reader task functionality. Those images that meet the inclusion criteria for your model development can then be assigned to imaging experts for interpretation and annotation, generating the ground truth for your model to learn from. Easily compare multiple experts' interpretations simultaneously in the viewer for rapid and concise adjudication. Flywheel orchestrates the compute setup, data staging, and authentication to streamline your ML development. Users can leverage existing frameworks to optimize training or define their own custom optimizers, schedulers, and loss functions. With your parameters defined, model training can be initiated. In this example, we used a typical PyTorch training process. The training loop was ran over 300 epochs, and the dice scores plotted for each. Note the improvement in model performance over time. With your model sufficiently trained, users can then validate its performance on a new dataset, reviewing the output directly in the ML environment. The notebook, model code, and outputs can then be easily saved back to your Flywheel project for reuse and sharing. To learn more about how Flywheel can help unlock AI advancements in oncology, contact us today.
Okay, so I want to thank everybody for allowing Flywheel to be here today, especially Despina, Sachin, and the entire community. We are looking forward to more and more being able to work with you as we get to do more on the tripartite overall. So we do appreciate being here. And if there's any questions, I'd be happy to take them. Also, like I said, if anybody would like a demo, please feel free to reach out to myself, Sachin, or Despina. Questions? Somebody had their hand up, I thought.
Hi, I'm a pathologist. And,
Okay.
So all through I'm sorry, Zlat, I couldn't attend. I just got
It's okay.
into this.
We're glad to have you now.
I have this general, almost a rhetorical question. You know, as you go from 16-bit to essentially which will yield you something like 6,000 shades of gray, and we move into an arena where we have RGB, 24-bit, which will yield about 1 billion different colors. Mm-hmm. How do you begin to try to integrate those different platforms? Do we just start with metadata coming from Flywheel and integrating that with images that we have in digital pathology? How do you begin?
So the first thing I'm going to say is I'm so happy the first question came from Digital Path, because that's that's one of the areas that we obviously, I think, all know that we have to become better in. When it comes to digital pathology in general, I'm not going to sit here and say that Flywheel is a digital pathology platform by any stretch of the imagination. We have some limited capabilities when it comes to digital path and our ability to ingest it, and kind of a Google Maps slide view of the ability to kind of view it. We don't have algorithms that are specifically built or gears that are meant towards the digital pathology side. However, with our Python SDKs, we have people who do develop their own and then import those into the system. So to answer that, to answer your question, I don't think I can, to be perfectly honest with you. I would actually want to defer that maybe more to some of the people in my engineering team. But what I can tell you is that specifically digital pathology, we understand the importance of it, and that it's basically the holy grail when you think about if you can bring digital path, DICOM, and your tabular data together. So that's certainly top of mind, and I think as we get further down the road, that's something that you will see come out. But unfortunately, right now, it's not really one of the top of mind pieces of it. I think as we get a little further down the road, you'll see digital pathology become a bigger part of what this platform is.
So right now at Columbia, we have two different digital platforms. We have PathAI, which is on the clinical side, and then we're using the Proscia platform on the research side. We have completely separate entities because we just don't want to mess around with PHI and PII. Okay. And so we have chosen on the research side a platform has a pretty open API.
Okay.
And we're working with Proscia to actually develop industry partnerships. So it would be interesting to try to model different ways of developing industry partnerships by integrating our different approaches.
And we are very open to those conversations, and we would like to have those conversations with folks. So by all means, that is something that we would definitely like to pursue with you. Sachin, did you have something you wanted to mention there?
With your open API and with Docker as platform, you should be also able to.
I think, again, as I was saying before, if you can use an S3 or blob storage basically as an intermediary because of the open APIs, and if you wanted to automate it, you can schedule a cron job and have it delivered back and forth. That's certainly something that you can do today. If you were thinking as like a true integration, that was kind of where I was talking about we should have further conversations. But yeah, absolutely. What Sachin just mentioned is that Flywheel is ultimately very integratable with almost anything as long as you have the ability to export and import. Flywheel gives you the ability to export directly to AWS S3, blob storage, and things of that nature.
And also you can have these analysis pipelines which can generate tiles as a digital path data is imported to Flywheel. So that your path data and your imaging data can stay together as well.
Yes, ma'am.
So, for example, if I was to set up a project and I import the images into the other DICOM data into it, and then what kind of post-processing softwares do you have? Do you have to kind of post-process it on the side and then pull it back, or is this just a data storing mechanism? Or can you do some amount of post-processing in it as well?
So it depends on what you're looking to do. We have what's called a gear library that gives you somewhat, I don't want to say infinite, but there's about 150 different Dockerized algorithms for a lot of the different processing needs that you would need that you can choose from there.
And so those have to be it's like you have to write a code for it, or?
So within Flywheel, we have what's called our gear library, and so those gears are already Docker containerized. All you have to do is select them from a drop-down menu when you're creating your automated pipeline. So any of those algorithms are already available to you. If you had an algorithm that you wanted to Docker containerize yourself, that can be uploaded into Flywheel and viewable either in only a project. If you only wanted to share that algorithm within that project, you could share it. You could have it be shared within the instance so that anybody from CUIMC would be able to view that. Or if so, you wanted it to be something that was public, you would work with us and we would actually Docker containerize it and make that part of our gear library and make it public for everybody if that was your choice. But yeah, so there would be the different ways.
So like total segment data is available as public. They have care, Flywheel care for that. So you should be able to
Yep.
utilize it on all your data if you want to segment it from CT algorithms.
That's correct. We had a question in the back?
Yeah, so mine is like a twofold question. Like the most time-consuming part for any of this image analysis is the having, like query data sets. So for the training part, like how Flywheel can help, for me to create those data sets, let's say adult gliomas or pediatric gliomas, and then once I have trained the model, that's the second question, how Flywheel can help validating that algorithm in real time.
Okay, I'm going to ask, I didn't actually get your whole first question, but I can answer your second question because I did hear that whole thing.
Sure.
So I'm going to jump to the second one quickly. I had mentioned earlier about the longitudinal validation. So because the system allows for direct ingest, and whether that is through a connector or you're pulling from packs, you have the ability to over time consistently run new live data through your AI algorithms so that you can look for drift, shift, anything that would be going on with that algorithm. So that would be the way that we look at the longitudinal validation. I apologize, I didn't catch the first question.
Yeah, the first question is basically, for training the model, I need the data, that is clean.
Right.
Right now, the problem that I have is, it takes a lot of time.
Yes.
To create those, specific data sets, that I need my models to train on, let's say adult gliomas or pediatric gliomas, like you mentioned, for certain age or with the certain identifiers, I would say data discovery part.
Gotcha.
How and, Flywheel can help with that.
Yeah.
I think you said something is going to come.
Yeah,
So if you
absolutely. So two different ways. So one, within Flywheel, there is a dynamic search. So anything that has been ingested into Flywheel, you have the ability to go through and dynamically search in basically that very Zillow type of way. So, if you're looking for a home and you filter down through, price range and that, we have a very similar type of a search within the Flywheel platform that allows you to search through any data that has already been uploaded into Flywheel. Now, as we think about data, because we know, everything we talked about was hidden data and all the data that may be residing in NYP or in different places. One of the things that we're looking at now and that we're in the process of is a framework for a cohort builder that would allow us to access data from the VNA and PACS. And so that is still kind of in the initial stages of building as that's coming out. But that will be something that would allow for you, basically exactly the way I talked about it. If you wanted to do kind of a sequential search where you would look through and say, I need males between the ages of 40 and 48 who have heart disease and they have a glioblastoma. You would be able to go through, and that would help you parse out all of the data that would be into the VNA. It would then give you those results back, and you would be able then to say, okay, I would like to bring the pixels across with that, not just the metadata. So that is something that is coming down the road as part of the overall system here, and we should be able to see that within the next 12 months or so. Currently in the system, we do have the dynamic searchability of anything that has already been brought into the system. So does that answer the questions?
Yeah, thank you.
Any other questions? Yeah.
Hi, I have a quick question regarding the containers pipeline. So you mentioned Flywheel provide containers pipeline for pre-processed data, right? Do we have like a QC besides the pre-processed data? So we want to know, for example, for T1 structure scans, which one is good, which one is bad? Do you have like a QC?
Yeah, so
procedure?
You're talking about the QC measures, yes.
Yes.
So there is QC. Actually, in the system, as you run anything through a pipeline, anything that doesn't come through, anything that doesn't process correctly, if there's any errors that are found, it would automatically flag that so that when you sat down at the console, it would tell you that there was an error in the data or there was an error in the analysis that was being run. Now, you're asking about quality control specifically.
Yes.
We have, so again, when you think about some of the Dockerized algorithms, again, if you look at something like thank you. Yes, we have algorithms. My apology, and I'm blanking on the name of the algorithm. My apology here. I think it's QSI prep, but that actually gives you. So when we do say a neuro workflow or a neuro pipeline, that actual QC is part of the pipeline, and you get those results as part of that initial when you sit down. So that would be a gear that got run. It would go through and it would give you everything from signal to noise ratio. It gives you a visual inspection sheet of all of the slides that's in HTML that you can view, as well as all of the provenance and governance records that come out of that algorithm.
Yes, that's basically it's offline, right? Do you have a plan in the near future can do real time?
No, that part is actually online part of the system
It's online
currently today.
process.
Yeah, that's all that works. That's part of the system. That's part of the normal out of the box Flywheel.
Okay.
I don't really love the term out of the
Do we
box
need
Flywheel.
to pay extra money for the
No,
QC?
not for as far as Flywheel is concerned that I'm aware of. I don't, that is part of our system. How it might work here from a licensing perspective within the center, I wouldn't want to speak to that. Despina can speak to that.
Okay. Yeah, because we don't use Flywheel, instead we use XNet. I believe XNet and Flywheel are same company, right?
No, and actually I'll address that right now. So,
okay.
and no, that's okay because that's a very common misconception because we were the same company 6 months ago.
Okay.
So we did own Radiologics and what was the open source arm of Radiologics, which is XNet. We had actually purchased that company about 3.5 years ago, and they were part of Flywheel. At the end of December last year, we divested in the XNet piece of that, including all pieces of it, which would include their the discovery, which was their idea of a cohort builder, as well as some of the overall XNet open source has now gone back to the initial creators. And there is a new company, there's actually 2 new companies that have formed to support open source XNet projects that might be going on. But because of the fact that we had the experience for 3 years bringing them in, the 2 platforms may seem very similar. But they're very different in the way that they were built from their tech stacks. They're very different in the way that they're approached in the grand scheme of things. The systems don't operate the same way. They weren't built XNAT wasn't purposely built for the cloud. Flywheel is a cloud-native application.
Cloud-based, yeah.
There's a lot of different things that we could talk about that would differentiate that, but just as an awareness for everybody, XNAT's entities, all actually no longer part of Flywheel as of the end of 2024. As we entered January 1st of this year, Flywheel was its own entity.
Okay. Sorry, last quick question.
Yeah.
Regarding the Flywheel, do we have a plan in the near future can provide a public available data sets attached to Flywheel? Because right now, for example, if we upload our own data, right, so we can pre-processing and post-processing, and we now have tons of public available data sets, for example, ABC study and HCP studies, right? So they have tons of public available data sets. So if we can process, download the pre-processed data from Flywheel, that would be great.
Okay, so I think what you're asking for is you're looking to have some of the data sets from like ABCD and some of these other very popular data sets actually brought into Flywheel?
Yes.
Was that the question? Okay. So I think that's something that we already have some data sets that may be in there. I believe there's BROTS might actually be in there, or am I making? Yeah, I believe the BROTS data set is in there. I'd have to check to see what other ones are available, but that is something that we could try and work around with you, so.
Okay, thank you.
Any other questions? Okay, well, thank you so much.
Thank you, Howie, so much. And I just want to summarize a few things that we could do with Flywheel today. First of all, our website has launched as of today, www.columbiaradiology.org/CIMBID, also linked through VPNS. And one of the several pages there is a page that has a form that you can contact us to request an account for Flywheel and a description of what you'd like to do. There are a lot of things you can do. If you have data set and you're just looking something to upload and code and run computations, you can do that. If you want to use Flywheel as an intermediary to pull data out of the health system today, you can do that. We have a VNA connector. We don't yet have the cohort functionality built in, but we will have it by the end of the year. But if you have submitted a track request, and you have a list of accession numbers for imaging studies you want to access, and you give them to us, we can get the data out for you, de-identify them with sort of Columbia-approved data identification profiles, organize them, and make a shared folder that we can give to you, right? So there's a lot of things you can do with Flywheel. You can contact us. You can get an account today. Tell your friends that at least until the end of the year, Flywheel will be free, right? So this is the time to dive in and use it, see if you like it, and tell us if you like it, what you like about it, what else you'd like to see. And then after that, we will try to develop a sustainable model for access, very reasonable pricing that the center will subsidize to make sure that investigators can have access at scale for imaging data, use the platform to develop AI models, deploy gears, tools, and help the clinical translation to the clinic. So before we end, a few things I'd like to say. So today, CIMBID was born, and there are a lot of people who have contributed to this. The website is up. You can visit it. You can find updates. We will create a mailing list. We will keep updating you about what is going on. And every year, on June 16th, we will be celebrating CIMBID's birthday by a little research retreat that you're all going to be invited to come back and hear what's happening and present your own research related to CIMBID and so forth. As I said, there's a lot of people I'd like to thank. We'll probably sit here for hours, but I would like definitely to thank a few people. The whole CIMBID team, investigators, scientific steering committee, everybody who you saw here today, coming together and help put this in pieces. I would like to specifically thank Dean Armstrong for her vision, who planted the seed that created CIMBID. Dean McKiernan, who helping us getting through the turbulence in these days with his support. My total and absolute partner in crime, Ajay Gupta, our department chair, his unwavering support through this crisis, did not even blink, did not even see the cost of putting this together. And I am so grateful to be able to build this together. The radiology administration team, who has been supporting this throughout, the dean's office, Vice Dean Rudy Ode Ramadan, for the countless hours we spent last summer figuring out what even a Type 2 center is supposed to mean, as we were one of the first new Type 2 centers for the university, the structure, the financial planning, the projections, all of that went in place. Jen Williamson, Will McCoy, as so many other people. And specifically, I want to thank the people who made today's event happen. Karen Thorne downstairs at the registration, Latricia Staples, and the two superheroes. I did promise we'll get them capes that say CIMBID superhero. Yenthel Monestein Wheeler back there. Give her a round of applause. 24/7, around the clock, getting this happen. And Sarah Durham, Director of Communications for Radiology, for getting this together and everything. And for me, I think, we had a lot of debate. Should we do this now with everything that's going on, the turbulence, every day it's struggle, should we do it, should we not do it? And one of the big reasons that we decided to launch despite the storm and keep going is, I think, at least for me, and I hope I'm speaking for several of you, what CIMBID represents is a reminder of who we are and why we do what we do every day. And it's an opportunity for us to come together and support each other through what is going on these days, and to help us move forward with a vision that can be inspiring to all of us on a daily basis. So thank you. Let's make it happen, and come downstairs for some drinks and some hors d'oeuvres to help close the day on a positive note. Thanks again. Thank you very much for being here today.